My name is Kashyap Wadrabu, and my default ID is 1877243. And this is a Jupyter file on which I did my final project for machine learning CSC-478. So I'm getting the data from the CSV files that I have downloaded from UC Irvine Machine Learning Repository. And so this is the white wine data and red wine data. And I have performed regression, basically all the supervised learning algorithms on both the data sets. So this is just showing the shape of the data and the column names and the data types, describing the data, etc. So now here I'm normalizing the data frame so that all the values of all the columns are from 0 to 1 so that the regression would be accurate. So these are representations of different features and histograms. This is where we start the supervised learning, and here I'm adding the extra column that have all ones as values so that the calculation would be easy for regression. So, and then here I'm performing the simple linear regression, and these are the root mean square errors and mean absolute error values. And then I'm performing it on red wine data as well. And this is the graph showing the difference between real and predicted values. And even though this is a scatter plot, since the value we are trying to predict are like, single values, 5, 6, 7, 8, something like that. So that's why this is like this, the graph is like this. And here I'm performing the same linear regression using K4 with n is equal to 10. And then I'm calculating the root mean square error, average for all the folds, average RMSE for all the folds. And these are the values. So this is where I'm doing the feature selection. That is, we select a limited number of features rather than all the features to perform regression. But for this particular data set, it seems like using all the features would be better for regression. The regression prediction would be more accurate. So this is where that shows these are the graphs that shows with increasing in the number of features selected, the error is being decreased. So for both white wine and red wine. And now here I'm doing the regularization, the region lasso regression. So here I'm trying to find out the best alpha value for it, and then comparing the MAE for normal linear regression and the ridge regression. As you can see, ridge regression did better. So I did the same thing for lasso for both white wine data and red wine data, and even here the lasso seems to perform better than the simple regression. Now here, these are the values using ridge and lasso, and by looking at it, we can see that ridge on white works better and lasso on red works better. So that's what I would select for regression. And here I'm doing the stochastic gradient descent model and grid search to find out the best values for the parameters that we can put in SGD regressor. So these are the values I have given for the grid search, and these are the values that are optimal. So I'm calculating the MAE and did the same thing for red wine and white wine. And here I'm calculating the best 11 ratio. And these are the error rates for all the regressions that I have used. And by looking at these values, the ridge regression for white wine and lasso for red is the best way to go. And now we are in the classification section. Here I am, changing removing the extra column that I have created, and then uh, non-normalizing the target so that we have integers as classes. So this is just pre-processing the data, splitting the data into train data and test data. This is where we are performing the classification using different classifiers. And now this is using KNN classifier, and this is using KNN classifier. K is equal to 9, and this is where we use different number of K values, and using a non-weighted KNN classifier. And as you can see, the values are gradually decreased with the increase in K, and it's the same for white wine as red wine as well. And so this is where I calculated that for the red wine, and the same thing for red wine. And then I calculated using weighted KNN classifier, and here I found that the precision and recall has been increased with an increase in number of neighbors. Here I'm using decision tree classifier, and I'm using the non-normalized data because we don't need that for decision classifier. And there is a report for white wine and the report for red wine. And the same thing with the naive-based classifier. And this is where I'm doing the random forest classifier. And here I'm doing a grid search on certain parameters of random forest. And I can do that only for white wine because it's taking a lot of time. So I did only for the white wine data. And these are the parameters I used: min, max, split, number of estimators, number of jobs. And these are the optimal values that I got after performing the grid search. And now if I use those values as parameters for random forest classifier, the error has been reduced. The MA has been reduced from 0.36 to 0.32. And this is the report without grid search, and this is the report with grid search. And as you can see, the precision recall has been increased. So this is performing the random forest without grid search for red wine. And these are all the accuracy scores, errors for all the classifiers that I have used: the KNN, tree, naive base, random forest, without grid search, with grid search. And these are all the reports for all those classifiers. By looking at this, random forest after performing the grid search did the best, so that I would choose that for classification. And this is where I'm doing the unsupervised learning for clustering. And the quality attribute is not logical to use as clusters. So I just performed clustering with different boulders of clusters, 5, and then 6, and then 7. And then I'm trying to recognize the patterns out of these centroids. Is centroid 5 clusters, centroid 6 clusters, centroid 7 clusters. And here some of the clusters are closely related. So even in cluster 5, the 0.4 and this 0.4, these two are closely related. So I'm thinking of reducing the number of clusters rather than increasing them. And 4 seems to work best because this is when all the centroids are different rather than being close to each other. And now since I found out that 4 clusters is perfect for this data set, here I perform PCA on these 4 clusters. And these are the centroids I got, and both of them are pretty much the same. Thank you.